Hi, I'm Dr. De Bruin, and this is a walkthrough of how to answer a question from the first topic of AQA A-level Chemistry, which is the atomic structure topic. So in this question, we're going to be looking at how to calculate the abundance of two different isotopes. Right since the very first topic of GCSE chemistry, you've been calculating relative atomic masses based on data that tells you about the mass and the abundance of two or more isotopes within a sample. This question is employing those exact same principles, but we're making it slightly harder by giving you the relative atomic mass and then also some mass data for the two isotopes and asking you to calculate the abundance. So it's the same idea, it just involves kind of rearranging the equation and using it in a slightly different way. So the first thing that you're going to need to do is to write an expression that connects relative atomic mass, or AR, the mass of the isotopes and the abundance of the isotopes. Now there are a couple of different options for how you lay this out. Your first option is to lay it out as a fraction. Now if I was calculating relative atomic mass, I would pretty much always go for this option because it means that if you're given absolute abundance data, so that's the numbers that may not add up to be 100%, they may add up to be 32 or 84, then this is just going to work much better for you because you can have a fraction with a denominator on the bottom of that total abundance. But if we're working with relative abundance data, where it's going to add up to be 100% or 1, then actually I personally prefer to use decimals because it means you can have slightly smaller numbers, slightly cleaner numbers, and it just makes things a little bit more manageable. So whichever option you've gone for, either one is fine. Once you've got that expression, you can start substituting in some numbers. So I'm going to take the decimals approach here. So I've got 16.1, that's the relative atomic mass that I'm given in the question. And then I'm going to make X the abundance of one isotope. And you'll notice here that I've picked my heavier isotope, my oxygen 17. Now the reason for that is that later on, if I don't do this, I'm going to end up with some negative numbers. Now negative numbers are fine, we can just divide everything by -1 to get rid of them, but it just means that I'm not going to have to do that step later if I've used X as my heavier isotope. Now, I know that all of the isotopes together are going to add up to be 100%, or if I'm working in terms of decimals, they're going to add up to be 1. So therefore, my second part of my expression, where I've got the abundance, I know that that abundance, together with the abundance that I made X, they must add up together to be 1, or in other words, 100%. So this is where this 1 minus X has come from. So then if I then multiply out my brackets, I'm going to end up with 16 take 16x. And if I then simplify by gathering together those x terms, I'm left with 16.1 being 16 plus x. And you can see here, this is why I want my heavier isotope to be X, because if I did it the other way around, then I'd end up with a minus X term rather than a positive X term. So if I take 16 away from both sides, I'm left with 0.1 being X. Now remember, if I'm working in terms of decimals, 1 is 100%, so 0.1 is 10%. So I need to finish off my question by actually telling them what the abundance of the isotopes are. So I'm going to have 10% of oxygen 17, because X was my heavier isotope, remember? And then therefore, because the isotopes have to add up together to be 100%, I've got 90% of oxygen 16. Thank you very much for watching, and I hope you found this a useful run through of this question from the atomic structure topic. If you did find it useful, then don't forget to like and subscribe, but also comment and share the channel, and I'll be back with some more A-level chemistry walkthroughs soon.